They and GAN are two types of generative models. A generative model is a type of statistical model that through AI learning can create its own unique data instances based on training data input into the machine. For example, a generative model could be given 5 images of cats as training data, which it will then use to generate a completely artificial image of a cat based on the parameters of those images. The cat the computer generates an image of won't ever actually have existed, though the goal of GAN is that the image will appear real enough to you and I that we will not be able to differentiate the authenticity of it. A GAN is then a step above generative modeling in its addition of a discriminator to assess the authenticity of the generator's output. The discriminator is tasked with distinguishing the real data from the fake data. The two neural networks compete, with the generator attempting to deceive the discriminator into marking its content as real. Veys are autoencoders which process data using an encoder and decoder. Veys encode their data input and convert them into a vector, which is then reconstructed by the decoder to produce the input sample. Based on its sole process, Veys don't provide anything of note in their output, but rather their ability to create vectors legible in computer language provides a more specific latent space during data sampling for generative models to match their generated content with real-life images. In looking at the technologies used in Studio One, traditional methods of coding have been utilized over machine learning algorithms. Rather than instructing a set of computers to learn from a given dataset and create content, the studio writes code to instruct the computer, using manual input to fulfill tasks. Cost and time efficiency in training AI, as well as the strain placed on studio machinery, makes the process of manual coding more desirable. Machine learning could be utilized in Studio, but its full effect would take time to develop in the current environment. Though Veygan modeling has not been used in this project, it is possible to apply generative modeling to various areas of the pipeline. These neural networks are flexible in the way they can be used, while also being time efficient once their training framework has been established. Can be used in audio sampling, anti-aliasing, and human image synthesis. In the context of our project, Veygan image synthesis could be used in place of stock images that populate the environment, or to enhance our human characters that have been created using Unreal's metahumans. Post-production tasks may be shortened considerably through the use of Veygan as well, such as image reconstruction and colorization. GANs are difficult to train as compared to Veys, and due to their adversarial nature, require more supervision during training. As both the discriminator and generator attempt to avoid loss and generate wins, the competitive nature of the two networks makes creating an even win-loss scenario finicky. The time required to research and develop a possible training method for these neural networks could take time away from the project at hand. The addition of Vey and GAN neural learning would be greatly beneficial to Studio 2's project. Though the initial setup may cause some delay, the effects of Veygan are far-reaching and valuable to the production of assets. Concerning the production control and quality of the project, Veygan can be used to improve our output through image and video production. As a method of human image synthesis, major changes can be made to the authenticity of our characters. By using Veygan, we may better match the minutiae details of the face that are otherwise omitted in normal production at a much quicker rate. Image-to-image functions may shorten the time spent on conception of characters, as artists are able to quickly mock up designs using Veygan before pushing developed renders. Super-resolution imaging and video prediction would greatly benefit the time spent in post-production editing, as these neural networks may fill in content lost during rendering and up the resolution of lower-definition content. Photo blending can produce photo bashing content in a much more streamlined and higher quality format. The issue with all-encompassing content is the grounds on which it can be produced. Veygan is costly to train, with NVIDIA's style GAN requiring between $2,500 to $3,100 over 41 days to train the neural networks in a set algorithm to produce at the desired output, which would require refinement with the particular style we want to achieve in our project. If compared to the production costs as is, we may save time and money in the areas that Veygan can produce unsupervised. As Veygans can be difficult to train and still emerging, this may be a high-risk loss of money and time, though based on the many beneficial qualities of these neural networks, it would also be high reward in the range of time-efficient content produced at high detail and accuracy. Veygan is relevant to the future of the industry in that it has far-reaching effects on the way we create content and view it. It challenges our perception of human image synthesis and is groundbreaking in its accuracy and ability to sail over the uncanny valley. It also dictates the way in which we connect with characters on screen, adding a level of immersion in cinema. The long-term effects that vague neural networking offer would be extremely beneficial to the 3D industry. As an emerging tech, finding a viable solution to setting up this type of AI would see huge improvements along the pipeline and in audience reception of animated content as well.